Hello, this is question 2 on your AS level mechanics paper from June 2022 from Edexcel. So you have a train travels along a straight horizontal track from station P to station Q. In the model of the motion, at time t0, train starts from rest and moves with constant acceleration until it reaches maximum speed 25 meters per second. Then the train travels at this constant speed before finally moving with constant deceleration until it comes to rest at Q. Time spent decelerating is for the time spent accelerating, and the journey from P to Q takes 700 seconds. So first thing we have to do is to sketch a speed time graph from the motion between P and Q. So let's see what we know. So we represent the axis, velocity, time, and this is meters per second, and they say it accelerates until, so it starts from rest, so I'm going to start here, accelerates up to 25 meters per second, then stays at that constant velocity and then decelerates, and the deceleration is, the time spent decelerating is 4 times the time spent accelerating. So it accelerates up to 25, let's say this is 25, stays with constant velocity for some time, we don't know, and then it takes longer to decelerate. So I'm going to do this line more slanted, but I don't think it's that important. And we know the whole trip takes 700 seconds. So I know this number and I know this number, and I don't know anything else. And it's 1 mark. So the mark is going to be really for the shape. Yeah. So as constant acceleration, straight line up, constant velocity, horizontal line, constant deceleration. Yeah. Then the distance between the two stations is 15 kilometers. Using the model, so that the time taken accelerating is 40 seconds. So we know that the area under the graph is going to be the distance. So the area is going to be this 15 kilometers, right? We need to write an equation for the area in terms of the time, because we don't know the times. We know the total time, but not the bits to find the area of this trapezium, right? So we know this side is 700, but we have to write this in terms of t to find this t40, right? So if we call this value, this time t, so we say this is t, we know this bit is 4t, because they say it takes 4 times decelerate, and this bit here then it will be 700 minus 5t. So this is a way of writing it, but this is not the only one. So the area of the trapezium is going to be long side, so it's 1/2 long side, short side, so we have 1/2 of sum of the parallel sides, so it's going to be 700 plus 700 minus 5t times the distance between the parallel sides, which is 25. Yeah, and this is going to be equal to the distance. The distance, be careful, because it's in kilometers and all our numbers are in meters, so I have to write 15,000 in meters, right? And from here you just solve for t and then you get the 40 seconds that you need to get. Yeah, so it's not difficult. You just need to remember that the area is the distance. Then it says find the acceleration in meters per second square of the train. So the acceleration is this bit here. We know we can use subat because it's constant acceleration, or we can use the idea that the gradient of the velocity time line is going to be the acceleration. So the gradient of this line is the change in y, which is 25, divided by the change in x, which is 40 that we just found, right? So for B, acceleration is going to be 25 divided by 40, which is 0.625 meters second squared. Yeah, that's my acceleration. Then for D, they say find the speed of the train 752 seconds after leaving B. So 572 seconds, we don't know well where we are. We don't know if we are accelerating. Well, we know because this is 40, so it's not accelerating, but still we could be here maybe. So we have to check where we are. this is 40, this is 700 minus 5 times 40, which is 500. So this is 500. So here is 540 seconds, right? So if we write the seconds, this would be 40 seconds, this would be 540, and this would be the 700. So if they are asking us 572, that means that we are somewhere here in the deceleration, right? I would use Subat because it's decelerating, and I think it's the simplest way, but I'm sure there are another ways of doing it, like the gradient of a proportion in the triangle. Yeah, if we write Subat, we don't need the displacement. The initial velocity is 25. Final velocity is what we need. We know that we are talking about 540 up to 572. We are talking about this motion here, not the whole thing, because the whole thing is not constant acceleration. So I'm talking from here to here. So it's 572 minus 540. So 32 seconds is my time, the time that passed where it's decelerating. And the deceleration is going to be negative because it's decreasing, and it's going to be a quarter of the acceleration because it takes 4 times the time. The gradient or the acceleration is going to be 1/4 of the one that we found. The one that we found is this one. So my deceleration is going to be minus 0.625 divided by 4. And with this and Subat equation without S is going to be V is U plus 80. So my velocity is going to be 25 minus 0.625 divided by 4 and then times by 32. And this is 20 meters second. That's the velocity, right? And the last part, they say, state one limitation of the model which could affect your answers to part B and C. In all these constant acceleration questions, you always can mention that in real life, acceleration is not really constant. So these curves will be more curvy. So these lines are not really straight lines. They will be more curvy. So it's like constant acceleration is not really constant. So in real situation, acceleration wouldn't be constant from beginning to end. That's what I'm writing. Wouldn't be constant. All the way, yeah. So that's what happens with these questions. And that's all.